Human beings have always been driven to create new technologies, not just for themselves, but for greater good of the entire world. One of the most remarkable inventions in recent time is generative AI. But how can we harness this powerful technology to turn the difficult task into simple ones? How can we unlock the full potential of AI across all aspects of our life? That's the journey that we are exploring in today's episode. Hello, everyone. Welcome to Data AI Express, your data and AI companion. This is the ultimate guide series on generative AI, a complete breakdown to help you learn everything you need to know. We are bringing you to the core concepts, latest updates, practical insights that will surely benefit you. Let's jump into the video. Generative AI. Generative AI isn't just a single function. When we train a machine, we feed it with massive amounts of data, fine tuning it at every step to improve its output. The final product, the generative model, is built on billions of parameters that have learned from this diverse data. For example, if the model has learned from the sun rises in the east, when you ask which direction the sun rises, it will automatically answer correctly. That's the power of training machines with enormous data sets encompassing endless text, images, music, and video. When you ask a question, the model generates an output based on its learned information. Traditionally, AI models were built mainly to classify the data spam or not spam, is it human or animal. So, like the classification use cases, AI models were trained initially, or predict the outcome from the existing data using mathematics or statistics to predict what's going to happen next. If it happened, the function of the probability is y equal to f of x plus so and so. So these are the AI models use cases initially used. But generative models actually invent the new outputs from its trained data. Generative AI is a type of artificial intelligence that can create new original content rather than just analyzing or processing the existing data. So, where did the artificial intelligence begin? The history of artificial intelligence traces back to Dartmouth College during 1956, where a group of people brainstormed the idea of thinking machines. It all happened as a summer internship workshop in the Dartmouth College. This was the birth of AI as a concept. Though the idea was brought on 1956 itself, but nothing major leap happened in this area. For decades after decades, there is no growth. We used to call it a drought period of AI. Then by 1997, advances in mathematics, statistics, probability led to smarter algorithms. Machines began training on larger data sets, with each new step bringing better capabilities. For instance, predicting the next best move in the chess game by analyzing the current position and possible options. Machine learning became invaluable for decision making without needing the past history, just the present scenario. After the machine learning, the next breakthrough was deep learning. Deep learning is a subset of machine learning, where decisions are made using multiple data layers and even more complex. Imagine predicting the rain. You would rely on multiple parameters: humidity, wind direction, cloud pattern, temperature. There is multiple parameters put together in predicting the rains. That is how the deep learning works. Deep learning and machine learning are used in numerous use cases, whether it's a demand forecasting or predicting the image in the system. There are many use cases using deep learning and machine learning in the industry. So after that, the major breakthrough happened in the founding of generative AI. Generative AI is a subset of deep learning. It involves continuously training models on various data sets so they can generate realistic outputs, whether text, visuals, or audio based. On the context and the input that you provide, it creates an output. A major leap for generative AI was development of generative adversarial networks, GANs. It happened on 2014. Later, the transformer architecture, the famous attention is all you need, The paper was released in 2017. It completely changed the AI revolution. It is kind of a light bulb invention from Thomas Alva Edison. So after that, every industry started to train the model using this architectural pattern, and they started releasing one by one. ChatGPT from OpenAI was first released in 2018, and they have released an improved model year after year. In 2022, they have released the GPT-3, which is a multi-model which can able to seamlessly connect with text, images, and coding. Now in 2025, they have released GPT-5, which is the top notch, where it can choose the best model and it can able to connect various needful model. I have given a complete review on the GPT-5. Please watch out the video. I will put it in the description. So this field is growing faster than ever. For instance, if someone just joined the colleges as a fresher, they haven't even graduated yet, but the technology has gone somewhere far ahead. Let me explain how a large language model works with a simple concept. What you see on the screen right now, the DNA. Whose DNA? Is it human? Is it an animal? We don't know what DNA it is. But this DNA is what gives the form its identity. Let's assume if the DNA was a dog's DNA, then this DNA dog would be the result. They train the model using various DNAs like this. The DNA could result in a longer ears or certain colors or a skin type based on the small variable changes in the same pattern of the DNA. The output is generated, right? Look, the reason for this orange yield could be the orange growth itself. If the temperature, environment are certain way, it will grow like this. If it grows this way, it will produce certain yield. Similarly, if we provide water during this particular season, there will be a certain kind of growth. If the growth is in this way, it will give certain type of yield. If we provide fertilizer at specific times in specific way, we will get a certain growth rate. Various parameters at various stages decide the measurement. Based on this measurement, we can predict what type of output will it be. So we decide the output of various layer based on the various layer of input, various layer of parameters, various stages. Now, if we were asked, what's your name? We subconsciously know to say our name is so and so. In the same way, these models are trained in a pattern of questions and the pattern of languages we speak. So its output is decided based on its pattern history, which could be a dictionary or an encyclopedia or a general content. This is the concept on which everything works. We just saw an example how an LLM works. The paper in which this was discovered is called Attention is All You Need, which was released in 2017. I will provide the link in the description. You can go and check it out. This is called the transformer architecture based on the encoder decoder concept. So in that paper, they explain that when a data comes in, they send it to the model and they check the output after decoding the results. If it's correct, we proceed to the output. If not, we feedback to the encoder again to the model to produce the output. The circle continues until it's keep running into the loop until we receive the perfect output. So this is called encoder decoder concept. So I'm going to show you the program based on this concept. What you are seeing now is just a prototype of how the transformer architecture works. Now, what questions will I ask? I have given data AI Express will bring. I'm asking to generate. Let's see what it does. So based on training, data AI Express it generate will bring a. Okay, next will bring a whole. Let's see how it's coming up. Data AI Express. All these are separated words. Using the words data AI Express will bring based on a key, query, value, and various layers, it's predicting the output. It predicts what is the output could be. What you can see here is the temperature. The temperature determines its accuracy. Do we want a deterministic output, very accurate answer, or do we want some innovation to see what the output would be with the little imagination? Sampling is about how many samples to use. Let's increase the temperature. I have set it to 10. At 10, the imagination should be very high. When the temperature is very low, that's when it's create more accurate deterministic output. Now it says bring a new perspective. New is the predictor with 98.87% accuracy. After bring a the world, new will come. Okay, the new level of knowledge. I think this is what where we are going, right? You can see for yourself. This is the transformer architecture. This is how it works. We have clearly shown how it works. I will give you the link to the site. You should go and see it. Tokenization, token, embedding, positional encoding, final embedding, all of this are clearly explained. I just kept clicking generate to see what it has produced. So it has predicted data express will bring a new level of AI to the table. So this is all about our channel, right? Super. Now, how is a large language model created? They start with a foundation, a basic model. That's the brain. The data fed into it could be a text, image, speech, structures, or 3D signals. Based on these use cases, they train it. What kind of task do they give? They give questions and answers, sentiment analysis, information extraction, image captioning, object recognition, instruction following. With various tasks like these, they keep training the model. Remember the transformer architecture. If it has learned correctly, then okay. If not, repeated training again and again until it gets closer to the desired output. So imagine how much resources consumption probably for this training. That's why you see even for the recent wildfire incident in the California, some say the reason is the use of such a high resourceful to train the AI. Let that be hypothetical, but a lot of pressures are needed to create one model. To create a robust, trained generative AI LLM, it requires a lot of resources. Just in the training phase, that's why it's not easy for anyone to release one. Even if they have a lot of power, a lot of money, an investor, they can't just release one tomorrow. India is still trying to produce one LLM model from our whole country. That's why it's very difficult job. Now I have taken a comprehensive study of all the currently available LLM models. As you can see, the biggest of all is GPT-4. GPT-4 is trained a size of 1.75 trillion parameters. It is a multi-model. Multi-model is text, image, audio, and everything together in one single model. As you can see, the license type is closed. So various models will be of various types. Open models are open source. Anyone in the community can develop them. Meta's Llama's model is one of the open source model. Now you see GPT-4 was released in 2023. Its size is 1.75 trillion. You can pass a maximum of 128K input tokens. You can have a use case where you get maximum output of up to 16K tokens. Cost per 1000 input token. You have a watch this carefully. Every question is money. Every answer is money. So for every question, that is the input token, they decide the cost based on the size. They charge $0.05. Similarly, for 1000 output tokens, they charge $0.015. So you can use this for text, image, and audio. The next in size is Anthropic Claude model. This is also a solid model. It gives a balanced performance. It used for text and image. Look at its size. You can pass a maximum input of 200K. It will be the cheaper than GPT-4. Next is Gemini. Google's Gemini 1.5 Pro. Google has created a sister company called DeepMind. and it is creating all the LLM. The founder of the company, Purpose City, our own, uh, Tamil person Arvind, joined DeepMind as an intern and came out to start his own company. That's another story. We'll talk about it later. Now, Gemini 1.5 Pro from Google's DeepMind, look at its size, 1 million. It is the maximum input token size. As far as I know, this is the largest input token that you can pass. So if your use cases requires you to pass nearly a million parameter, it's better to choose something like Gemini 1.5 Pro. It is comparatively cheaper than GPT-4 and Claude. It supports text, images, audio, and video. Next is our Facebook Meta's Llama model. 70 billion parameter is its size. You can pass 128K input parameters. It is a text model. Next is the Mistral model. Grok, our Elon Musk Grok company. Look at its model size. 314 billion. It's the model weightage. Its charge is almost the same. That is Claude from Anthropic and Elon Musk company have the same charge. This is the multi-model for everything. This is when GPT arrived. There is meme going around, right? When GPT has released, it's saying that GPT is going to take all our jobs. But when DeepSeek has released, they were telling that, hey, GPT, I am here to take your job. So that kind of a cheapest model that they have released is through the DeepSeek. Look at its charge. It's 0.0005. GPT-4 price is 0.05. But DeepSeek is far, far more cheaper than the GPT. Beyond this, there are other models like Kohiri, Gamma. You can find out how recently it has been trained by its inference rate. Inference rate is all you need to know. Remember, that's the latest model trained data. So you can have to be very careful in choosing the model to use for which use cases for charge, because when it comes to the cloud, everything is cost. You should know the physics of cost in the cloud. Only if you control the cost, you can create a better use cases. For training purpose, there are trials. Every model provides some free capability with a limited capacity. You can easily train with that for various models and various use cases. Okay, with this, we have come to the end of part 1. What have you seen now? You saw the definition of generative AI. You saw the history of AI, where it started from 1956 to 2025. The history of AI, how generative AI emerged from it, when it started, the basic foundation of LLM, how it works, what are the key technical concepts, how foundation models are trained, what are their sizes, what are the various models created by various companies. We saw what you can train them for, what all the use cases are. I will see you in the part 2 of this video. Thank you. If you have some questions or comments, please do put it in the comments. I will get back to you. Thank you from Data and AI Express.